I think what we need to do is probably, I think we should do
the tangent alpha plus beta.
You want to do tangent alpha plus beta?
Yeah.
We can do that.
I messed that up on the whole.
Okay, so I'm going to keep these here. Well, it would be real nice if I had done part A and B, see? If I had done part A and B, because part B is cosine alpha plus beta, right? So if I did A and I did B, then getting D would be easy because I would just take my answer from A and B and I just make a fraction out of them. But if you're going to force me to do it this way, I will do it without the fractions. I mean, without it. I'm going to just... So for part D, tangent of alpha plus beta. So I need the formula for this then. Yes?
So would cosine alpha plus beta be the same as sine alpha plus beta?
No? No, because the formula for cosine of alpha plus beta is different, right?
I know they're different, but...
Or would they be the same value? Same answer?
Yes, kind of in a sense, same answer.
They don't have to be.
I know some answers, some questions, like, they have similar answers, like they might have a different sign.
Yeah.
So would one of them have like a different sign than the other?
It might not. It really just depends on what was given to you. It all depends on that. They could coincidentally give you the same value, but it's not guaranteed by any means. Or they won't always be off by a sign. It all depends on this. So if I were doing this, what I would do is I would just go to my formula sheet. Like if all I had was sine of alpha plus beta at this point, I'd go to this sheet, I would go to the formulas from last time, right? And I would look at that one right there, right? So this, by definition, is tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta, which would be equal to, now I need to get tangent though. See, I don't have a tangent on this information. But tangent's easy to get because I already know sine and cosine. So if I wanted tangent of alpha, because I need it over there, right? I would take the sine alpha divided by cosine. Take that, divide by that, and that's keep dot flip, right? So negative root 3 over 2 over 1/2, which is just negative root 3. Do I need to show that? Are we all right with this? What about tangent of beta? This over this, right? This over this. And you keep dot flip again, and you just get what? Negative root 8. And now I come back over here, tangent of alpha, negative root 3, plus tangent of beta, oh, well, it's a negative, I'll put it there, negative root 8 over, so that would become a minus, but I'm just going to leave it. 1 minus, and then tangent alpha, which is negative root 3, and then times tangent beta, which is negative root 8. That's a lot of negatives down there. I'll write this negative root 3 minus root 8 over 1 minus root 24. Those two you can put together because you're multiplying, right? When you multiply two roots, negative times negative is positive, 3 times 8 is 24. Put that under the root, and then the minus sign is still from here. I just leave it like that. Is that good?
Yeah.
All right, let's look at another. We're still working on the same problem. Let's see. How about let's do cosine of 2 beta. That's part F. I'm going to leave these here. Am I what? Can I erase? Yes? So this is part H, F. I'm asking for cosine of 2 beta, right? Not 2 alpha, 2 beta. Pay attention to the angle here, right? I want to know cosine of 2 beta. So when I ask for that, you have, what, 3 different formulas you can use, right? 3 different ones. Which one would you like to use? You want to use the second one? You can use any of them. So the second one is what? 2 cosine squared, in this case what? Beta minus 1, right? I'm going to use that formula. And I'm going to rewrite this as 2, let's see, cosine beta. I've got to square that minus 1. And that's 2. Now cosine beta, oh, it's 1/3. I like that. 1/3 squared minus 1. And that's 2 times 1/3 squared is 1/9 minus 1. And 2 times 1/9 is 2/9 minus 1. And that gives me common denominator, 9/9. 2/9 minus 9/9, negative 7/9. Hey, I got a negative answer. Right, I got a negative answer because I'm looking at twice what beta was, right? So I'm in a different quadrant now. So my x-coordinate's negative, I can tell you that right now. Do I need to do do I need to do a sine double or no? You want to do sine 2 alpha? That one's a lot easier than this one. I can squeeze that one in right here. I should do. How about sine of 2 alpha? The formula, there's only one option for this formula, right? 2 sine alpha cosine alpha. Go ahead and do that. While you're doing that, I'm going to look at something real quick. All right, this should become 2, let's see, sine of alpha is negative root 3 over 2, and then cosine alpha is 1/2, and this becomes negative 2 root 3 when you multiply across the top over 4, and that becomes negative root 3 over 2, because that fraction reduces. So I thought I would show you something while you were thinking about that problem. This right here is problem number 1. Whoa, that was problem number 1. Where'd it go? This is problem number 1 on my exam 2 for my Cal 2 that I just gave like 2 weeks ago. Nothing here needs to make sense to you, okay? Until we get to this step right here. This became this. Do you see, what is sine of 2 theta? According to us, what is sine of 2 theta? Yeah, so that becomes, oh, I can't write on this. Yeah, so, right? That right there becomes 2 sine theta cosine theta. And then you take half of it, and the 2 kills off the half, and you just get this. Right? So I'm not showing that step in a Cal 2 class. That's just a simple step. That's all it is. I'm just trying to show you like where this formula, they just kind of like pop up in different places, right? So we want to be comfortable with this one especially. This one comes up a lot, right? Later on. All right. What are we doing? Oh, we need to do one of these. Let's do either the beta over sine beta over 2 or cosine beta over 2. Which one do you want? You want to do the cosine? Okay. Cosine. Oh, it's alpha over 2. All right. Let's do that. I like that one. So for h, cosine of alpha over 2. Well, we know by the definition it's plus or minus the square root of 1 plus cosine alpha all over 2, right? That's just the definition off your formula sheet. Do we know what cosine of alpha is? Yeah, it's a half, right? Well, that's nice. Square root of 1 plus a half all over 2. I will accept that on the test, even though that's not hard to do, right? Put those together, whatever. That's not the important thing for me here. The important thing for me here is whether or not this is plus or minus. So which one is it and why? We're doing H.
Negative I.
Is it doing this? Oh, you're looking for the restrictions. Oh, there they are, right here. That's the restriction on alpha, right? So let's write that down. Negative pi over 2 less than 0. And to figure out what's happening to alpha over 2, I divide everything here by 2. So divide everything by 2. Negative pi over 4 less than alpha over 2 less than 0. So where are we? Still in the fourth quadrant, aren't we? We're still in the fourth quadrant because negative pi over 4 is here, 0 is there. So we're right in here, right in here. So we're right in this little region right in there. Like all that's not there. So if that's where alpha over 2 is, and we want to know cosine, that's the x coordinate, right? Cosine is the x coordinate. My answer should be positive. Right, we're somewhere over here, so the x coordinate, so I should be positive. Now, what if I had asked you for sine of alpha over 2? Sine of alpha over 2, that would change to a minus, right? And then this would change to a negative because that's your y coordinate, so you'd be down, wouldn't you? Okay. How are we doing on time? All right. There's nothing new. There's nothing else in this section, all right? I mean, well, I take that back. For the test, which is on Tuesday, there's nothing else from this section. So what I would recommend to you for your homework, okay? I know I said that this homework is due on the 8th, right?
Yeah.
That's the test date?
Yes.
Okay, so for this homework, for 8.6 homework, you're supposed to do it on the computer. I only want you to do problems 2, 3, 4, 5. 2, 3, 4, and 5. Those are all problems like I did today in class. The others you may be able to figure out on your own, but they're not going to be on the test. So let's just focus on that for now, and then you focus on the review. All right? And so I will postpone the deadline for this. All right? For the rest of it. Let's talk review. We have 20 minutes left. So is there anything on this review in particular that you would like for me to look at in the last 20 minutes we have? Have y'all looked at it or no? I hope you have. I gave it to you with plenty of time so you could go through it. I'm asking you to sketch on the first few, right? Y'all are okay on that? Do I need to go over any of that? All right. Yes?
Can you work on 11?
11? Which one do you want me to do? These are identities. D? Yes. And what's the most important thing when you do an identity? A lesson that we learned when I spent 40 minutes doing a problem the other day. What's the most important thing? Copy the damn problem down correctly, right? I believe when I die, I'm going to be sent to some math purgatory, and I'm going to get punished for all my math mistakes. Do you remember that time? My plan for the identities, because we all know these can be a little bit messy, right? You can get yourself stuck. My plan for the test is to give you a few identities and have you only do some of them. Like maybe I give you 4 and ask you to do 2. That way, if you start one, you get hung up, you can just kind of like, let me try another one. What I would like for you to do on the test, though, is do all the other problems and then, get to the identities later, because they can really get you stuck. And I don't want you spending 40 minutes on a problem and then you can't do any of the rest of the test because of that, right? So we need to verify this is true. So I'm going to start with the left side. Any ideas here? Common denominator. I mean, let's put them together, right? So if I'm going to put them together, I have to take the first fraction over here. I have to multiply the top and bottom, right? The top and bottom of that by what?
1 minus cos.
That one, right? 1 minus cos theta. 1 minus cosine theta. All right, now plus, now this fraction, sine theta over 1 minus cosine theta, and I'm going to multiply the top and bottom of that fraction by sine theta. Top and bottom. And now I start multiplying this all together. Everyone understand? Just getting common denominator? All right, when I do this, I have to multiply these two together, right? That's a FOIL. Or I could just write the whole thing squared. But I'm going to FOIL it out. On the bottom, this is 2 terms. That's 1 term. I can distribute, but I'm not going to. I'm just going to leave these separated. Same with these. I'm just going to leave this separated from this. And then on top, when these two go together, that's just sine squared. So let me do this FOIL. 1 times 1, 1, right? Then I do 1 times negative cosine theta is negative cosine theta. And then when I do the middle terms, I have another negative cosine theta. That's 2 of them now, right? Negative 2 cosine theta is in the middle. And then when I do the last multiplication, what does that give me?
Cosine squared.
Cosine squared, plus or minus?
Plus.
Plus, right? Because you're doing negative cosine times negative cosine, positive cosine squared theta. All right, everyone, that right there is these 2 things multiplied together without me showing the intermediate work of combining the cosines. All right, I'm going to have that plus, right, plus, and then the other 2, these 2 multiplied together, which are just sine squared, right? Ooh, do y'all see that? Do you see what I see? Do y'all see what I see? According to some of my neighbors, it is. Huh?
That's a nice 1 up at the top.
Yeah, it's a nice 1, isn't it? Everyone see that? Sine squared, cosine squared? Ooh, that's nice to see. That's a 1. All right, so if I have a 1 here and I have a 1 out front, I can put them together, right? Add them, and I have a 2. So now I have this. 2 minus 2 cosine theta. Is that all I have there? Yeah. All over. And on the bottom I have 1 minus cosine theta, and then times sine theta. Look where we're trying to get to. You see a 2 here? That's good. I see a 2 over here as well. But that cosecant, what is cosecant for real? 1 over sine, right? 1 over sine? Here's sine right here by itself. So somehow all this other crazy stuff needs to go away.
Factor the 2 in the numerator.
There you go.
Cancel out the 1 minus 1.
Factor 2 out of the top. See, they both have 2's? Right? Those both have a 2. Pull the 2 out. And that matches exactly what's in parentheses on the bottom, doesn't it? These 2 match. So they can cancel. They both have 2's, right? So you pull a 2 from here and here. You're just doing a GCF. You're pulling, oh, where did that come from? These 2 together. Add those 2 ones together. They're gone. You get 2 over sine theta, but that's 2 cosecant theta, and we're done. All right, what else? 13 minutes. So number 12, in terms of the test, number 12, I think I covered that thoroughly enough today that that should not be, I mean, you still have to do it, right? But you understand what you're supposed to do on those? Number 11, identities. That should be clear as well. I mean, we did a lot of identities. How about 10? Finding all the general solutions and then just the solutions between 0 and 2 pi for some equations. Would you like me to do one of those? Which one? You'll realize your test is not going to be this long, right? This is just to give you a flavor of what the types of problems could be. I'm not going to give you 4 trig equations to solve. Hey, what's up? Which one? B. Cotangent theta plus 1 times cosecant theta minus a half equals 0. I think you may have picked the easiest one, even though it looks like the worst one. After this one, it's easy enough we can finish it in like a minute and a half. The reason it's easy is because what you're doing is you're trying to figure out when something times something equals 0, right? So this is like already factored. So all you have to do is set each factor equal to 0, right? Set that equal to 0, set that equal to 0. So if I set cotangent theta plus 1 equals 0, I can go find the solutions to that. And then I can go cosecant theta minus a half equals 0, right? That's 2 separate equations. Here I move the 1 to the other side, becomes -1. Here I add a half to both sides, right? Now, in terms of things we're more familiar with, cotangent is the reciprocal of tangent, isn't it?
Yes.
So I could write tangent theta is that's the reciprocal of this, right?
Yes.
Now reciprocate this. So what's the reciprocal of that? Still -1, right? So now tell me about what you know about the unit circle. Where is tangent? At what angle is tangent -1? Remember, tangent's the y divided by x, right?
3 pi over 4.
So here and here, right? Those are the 2 places where tangent is -1. Now you know those angles and they're directly across from one another, aren't they? So I can get the general solutions by starting at the first angle, whichever one I want. I'm going to start here. What angle did you say that was?
3 pi over 4.
3 pi, so my angle here needs to be 3 pi over 4 plus, now to get back, well, to get to this one, I have to add pi and then pi and then pi and pi. So k pi? K pi? Pi k, k pi, doesn't matter where you put the k. What I've been doing pi k, haven't I? Yeah, it doesn't matter. It's multiplication. That's it. That's your general solution, right? Now, to get the answers between 0 and 2 pi, we can start plugging in different values, right? But because this is just theta and not like 2 theta or 3 theta or something like that, because of that, I can just tell you what they are by looking. It's 3 pi over 4 and
7 pi over 4.
7 pi over 4. Okay, so those are 2 solutions between 0 and 2 pi. That's my general solution. Now, what about this one? Yeah, it's undefined because we'll just use the same thing I did over there. Cosecant is the reciprocal of sine. So I flip that over and I make that sine, and then I reciprocate this. That becomes 2. But remember, the sine function can never spit out a 2, right? It's bounded between -1 and 1, right? So this is never going to have a solution. So you only have those solutions over there. All right, which other one did you want me to do? Either A or B. Yeah, let's do A. So for A, we have cosine squared theta minus sine squared theta plus sine theta equals 0, right? Boy, if that was a plus, I'd be happy, right? If that was a plus right there, I'd be happy, but it's not. So this looks like it wants to be quadratic, doesn't it? But I need either all sines or all cosines. So what do you think we should do? All sines or all cosines? All sines, because I have a sine here, right? Sine squared here. Let's turn that into something with sines. So use the Pythagorean identity on that. What does that become? 1 minus sine squared theta. Right, that's what that is. And then minus sine squared theta plus sine theta equals 0. I didn't really need the parentheses here, right? I just did that to stress that that became this. So this now becomes 1 minus how many sine squareds? 2 of them, right? 2 sine squared theta, and then plus sine theta equals 0, right? This is a quadratic in sine. So I'm going to move everything to one side of the equation. What do you say I take everything to the right? Since that's negative over here, if I move it to the right, it'll become positive. So I'll have 0 on the left equals I have 2 sine squared theta on the right. I have to move this to the right side as well, so that'll become minus sine theta. And I have to take the 1 on that side and move it to the other side as well. And then I'm going to factor that, right? Let u be equal to sine theta. If we do that, then this becomes 2u squared minus u minus 1. And then hopefully I can get this with the quadratic, or not quadratic, by factoring. Hopefully I don't need the quadratic. So does it work?
2u plus 1u minus 1.
Plus 1 minus 1. Yeah, I agree. That works. And once I have that, then I set each of those factors equal to 0, right? So I set those both equal to 0. So 2u plus 1 equals 0. And then the other one is u minus 1 equals 0. All right, this one is u is negative a half. This is u is 1, right? Here, move the 1 over, becomes negative 1, divide by 2. Over there, just add 1. Okay, what was u?
Sine theta.
Sine theta. And then over here, sine theta is 1. And now we're just going to go to our unit circle, right? This is asking me when which coordinate is what? Y coordinate is that, right? So here and here, right? Those two angles are not directly across from one another, right? So when we do our general solutions, we can't add pi k, we have to do 2 pi k, right? And so you're going to have to have 2 sets of answers. Your first set of answers are going to be start at this angle. So what angle do you want me to use for that? 7 pi over 6? 7 pi over 6 plus 2 pi k. That'll give me that first general set of answers. And then that one, what angle do you want me to use for that one? 11 pi over 6. And then add full revolutions, 2 pi k to that. Those are your general answers, right? And then to get your answers between 0 and 2 pi, well, you can just see them, right? Look, I was looking at the review and I realized after I sent the review that I never gave you, oh no, it's problems 9. See, problems 9, we have angles in there that are arguments that are not just theta, like 3 theta and 2 theta. That's where things get tricky because this becomes like 2 theta and you have to divide through by 2, or 3 theta and divide by 3. But I'm not done here, right? I need this as well. Where's sine theta 1? Pi over 2, straight up. So that means theta must be pi over 2, and then all the way back around, 2 pi k. All right, how are we doing? 2 minutes. Do you all know how to do 8b? It's going to be time to go here. If you want to leave at 2:40, you can go. I'm going to just do at least 8b. So just so we're clear, the exam is on Tuesday, right? Make sure you come fed and not tired and ready to roll. Bring the formulas with you, right? I'm not going to provide those, but I gave everyone a copy already, so make sure you bring those formula sheets with you. Okay, so I'm asking you to write this as an algebraic expression. Cosine of secant inverse of u. All right, so the way that I told you to do this in class is that you're going to first look at this, secant inverse of u, as being some angle. I don't remember if I called it alpha or theta or what. I'm just going to call it theta here. Right? Anytime we take the inverse trig function of something, that gives us an angle. Right? That tells me, from that information, I can say theta is equal to secant inverse of u. Which means that secant of u, when I take secant of this angle, secant of theta, must be u. So it's like I'm taking secant on both sides. Secant of theta, secant of secant inverse kill each other off, and I get this. Y'all follow me? Anyone know what I did next? What's that? Okay, I can rewrite that as a cosine. I could, yes. I could write that as what? Cosine theta is 1 over u, right? The reciprocal? Okay, that's okay. There's a critical step here. Anyone know? No? You have to draw a reference triangle. So what is cosine of theta? Adjacent over, or x over y, but back off the right triangle, it's adjacent over hypotenuse, right? So it's 1 here and u here, right? That triangle represents this equation right here. Now, why am I doing that? Because when you look back at this, right, take a step back,